Okay, so here is your test review. And I'm going to have to figure this out because we can't really see all of it, but we can see a little bit of it. And I'll have to shrink this. There we go. Let's go to 90%. Okay. Now we can at least fit the graph. Okay, so a couple things. The first thing it says, and I'm going to read it so I can find a copy of it. Hold on. Pause for station identification. It says, are the two triangles shown below similar? So the first thing that I want to do is prove that they are similar. So I'm going to set up a proportion. Image divided by pre-image to find my scale factor. So R equals AC is 4 divided by AC, which is 3. All of my scale factors better be 4/3. BC is 8 divided by BC is 6. 10 67/100 divided by 8. All of these give me a scale factor of 4/3. So if that's the case, they are similar. And then if they are similar, describe a sequence that would prove triangle ABC is similar to triangle A prime, B prime, C prime. So now we're describing a sequence. So step 1, we need to dilate by 4/3. Okay, so when I dilate by 4/3, this is going to get bigger. So this is about 11.5. We know it's going to be the same size. So here's where the problem comes in. When it's fractional units like this, we can't be exact, okay? So we know that we're going to dilate. We then know we're going to have to translate to the left. Okay? Because they're fractional units, I don't know exactly what this point is, so I don't know where it's going to go. And there's a bunch here. Okay? So notice how A's up top, A's down low. So we translated it to the left, and then we need to flip it. Well, how do we flip it? Well, we can rotate it, which sounds like the best idea, because we're going to want B down low, A up top. So after we translate to the left, we rotate 180 degrees. We're going to see another problem where we can be extremely specific. So this is a very rough way to do it. Find the dilation, put it. We know we're going to translate it to the left, to the left, and then we rotate that whole son of a gun around to make sure that it's on top of the other one. There's question 1. So now when we go to question 2, we get to start being a little bit more specific. In the diagram below, this one is similar to this one's similar to this one. Is this similar to this? Well, yes, they are similar because of the transitive property. If this is similar, that means they're all going to be similar. Now describe the dilation from here to here. This little guy means nothing to us. So the first thing I need to do is figure out R, which is my image divided by my pre-image. When we have this, I've had a lot of people say, Mr. H, how do I do a diagonal? You don't. If this one's similar to this one, all we need is one set of corresponding sides. And I'm going to use AB because it's straight on those boxes. 1, 2, 3, 4. There's 4 spaces here. There's 2 spaces here. So my image is 2. My pre-image is 4, which gives me 1/2. So my scale factor is 1/2. Does that make sense? Well, sure. It's shrunk. That's perfect. So now, step 1 to describe is we dilate by R equaling 1/2. Okay, so well, how do I do that? Again, this little guy means absolutely nothing. B is at 5, 4. So I need to multiply both points by 1/2. 5 times 1/2 is 2.5. 4 times 1/2 is 2. So there's the new B. A is at 1, 4, which comes to 1/2, 2. There's A. C is at 4, -2, which goes to 2, -1. There's C. As I look, this is now the same size as this one. We've done well. Hooray for us. Okay, so now we need to move this point all the way over. So how do I move A over? We're going to translate. So now I can be very specific. We are going to translate left. If this is at 1/2, 1, 2, 3, 4, 5, 6, 7, 8.5. Translate left, 8 1/2 units. So when I translate left, I've got something that looks like this. Does that match up? No. So how can I flip it up? This is where we have a reflection. So now I'm going to say reflect along A double prime, B double prime. Because when I reflect along that one segment, it flips right up on top. So again, there's certain steps. You're always going to find your scale factor first. Once we do that, 9 times out of 10, you're going to have to translate. Sometimes you'll be able to translate it right on top. But if it's facing the other direction, you're either going to need to rotate it. But in this case, we don't want to rotate it because that would move B and A. We simply want to flip it up, which is a reflection. Okay? You'll see a question like this on your test. Let's move on. That was question 2. Question 3 is a little bit easier. In the diagram below, you have triangle ABC and triangle A prime, B prime, C prime. Use this information. Are they similar? Well, we only have one angle, so we don't have angle. We can't prove it that way. So the only way to prove if these are similar, do they have the same scale factor? BC, B prime, C prime. So I've got 11 6600ths divided by 4 6/10. That better be equal to AB, which is 10 5800ths divided by 5 3/10. So let's see. So I'm going to get a calculator. And I'm going to do 11 6600ths divided by 4 6/10. And that gives me 2.5347, and it keeps on going. Then I do 10 5800ths divided by 5 3/10. And this gives me 1.9962. Wait a minute, Mr. H. Wait one gosh darn minute. Aren't these supposed to be the same if they're similar? Well, yeah. So these are not the same. So I would say they are not similar because the R isn't the same. Remember, R means scale factor. For them to be similar, the scale factors have to be the same for every single corresponding side because sides must be proportional. Okay? So that takes us through 1, 2, and 3. Proportionality is a huge part of this. That's how we're checking to see if they are similar. Ugh, got stuff all over my hands. Number 4. Okay. In the picture below, we have triangle DEF that has been dilated from center O by 1/2. The dilated triangle is D prime, E prime, F prime. It's right there. We also have triangle D double prime, EF, which is congruent to triangle DEF. Describe the sequence of dilation followed by a congruence that would map this triangle onto this triangle. So we're moving this one onto this one. Well, here's our thing. To get from DEF, we shrunk it by 1/2. The scale factor was 1/2 to get it here. How do I get it back to being big? And we talked about this. So step 1 is dilate. If we're doing the opposite, we use the inverse. So instead of dilating by 1/2, we're going to dilate by 2. So now this has become this one again. And then the only thing that we need to do to get this triangle onto this triangle is we reflect along segment EF. Why? Because this is a mirror. It folds on top of each other. So we have to reflect across that line. So again, it's telling us that this got dilated by 1/2 and this was our new figure. Well, to get it to go the opposite direction, we find the inverse, which is 2. It comes back to that figure. And then how do we get D to be over here? We fold it the other way, which is a reflection. It's reflecting along this line right here. And I think we have one more question. I don't know. We'll find out. I made this, so I should know. Let's find out. Here we go. Yes, one more question. Woohoo! Okay. Dilate angle ABC with center O in scale factor of 2. So we're multiplying these all by 2. So the first thing I need to do is this is 5, 4, this is 3, 2, this is 7, 1. So if I dilate it by 2, that becomes 14, 2. And that's A prime. B prime becomes 6, 4. There's B prime. And C becomes 10, 8, which is C prime. So there's my new figure. If angle ABC is 72, what does this measure have to be? It has to be 72 degrees as well, because corresponding angles, corresponding parts must either be congruent for angles or proportional for sides. So they have to be congruent. If the length of segment AB is 2, what is the length of A prime B prime? Well, if this is 2 and we have a scale factor of 2, remember the formula is image equals pre-image times scale factor. So 2 times 2 gives me 4 centimeters. And that's how we're getting that answer. So you have a test on Monday. You are also being given a second review packet that will not have a video. If you have questions on that review packet, you'll need to come in and ask for some help. Good luck.